So we are finishing up test 7, and you can get out your test. We were on question 44 because I had so many and we were getting kind of long in the video. I wanted to take a break. So let's finish up. 44. Which of the following elements is not an important nutrient containing in fertilizer? Remember in fertilizer you had kind of a ratio of 3 different things. So what the 3 of the things are listed here, but one of them is not one of them. So is it nitrogen, phosphorus, potassium, or oxygen? Well, nitrogen we know is in ammonia, and that's in fertilizers for sure. They need nitrogen. Phosphorus, yeah, phosphorus is in it, and potassium's in it. Which one is not in it? Oxygen's not in. In fact, nitrogen takes the place of oxygen, so oxygen cannot be united in this fertilizer. 45. What compound is used as a contrast agent for X-rays and GI? So if you go in and have an X-ray of your gastrointestinal tract, which one of these? Of course it's going to be barium, but what kind of barium is it? Is it barium nitrate? Is it barium hydroxide? Is it barium sulfate? Is it barium phosphate? So you just have to know. You actually could probably Google this. But anyway, it's not barium nitrate or hydrate. It's barium sulfate. So just have to know that one. I probably would have got that one wrong. But anyway. Number 46. What dense metal is used in car batteries, weights, and radiation shields, and small arms ammunition? Okay, think of it's going to be very heavy because it's used as weights. It also, when you go into the dentist and they're going to x-ray your teeth, they put on this apron that's really heavy. What is it made of? So is it, what is it made of? Is it made of tungsten? Is it made of zirconium? Is it made of uranium? Or is it made of lead? What do you call it? Lead weights, right? Lead weights are heavy. Lead. So let's see. Number 47. Which of the following is not a method of hardening steel? So A, cold working. B, annealing. C, case hardening. Or D, quenching. Well, the first process is annealing, and annealing is not hardening the steel necessarily. It's basically putting it at high temperatures, So this is kind of a tricky question because, I was thinking of probably cold working when you're working on it, but actually that hardens the steel as they press the steel in. So, and quenching is hardening the steel. We know that for sure, and so is case hard. So I would say annealing. So 48. What is the cheapest and most widely used metal? Is it zinc, aluminum, brass, or iron? Which one would be the cheapest and the one that's used the most? Well, when you look at that, you think it might be aluminum, but it's not. But the cheapest is actually iron. So iron is the cheapest and the most widely used. Number 49. What metal is used to make the windows in X-ray tubes? Aluminum, gold, magnesium, or beryllium? So you can look that up because I was thinking of which one too, but I would think of beryllium as aluminum. X-ray tubes, no, gold, magnesium. So number 50. What is the primary component of window glass? What is glass made of? So is it made of silicates? Is it made of aluminates, borates, or carbonates? Of course, glass is made of silicon. You know that? Just like computer chips, but it's a type of silicon which is mixed with oxygen called silicates. Which of the following physical properties is not characteristic of metals? Number 1 is a poor electrical conduction. B is ductility, malleability, and luster. Well, ductility, malleability, and luster are all about metals, and metals are good conductors, not poor. So, of course, that's pretty easy. It would be A. What very dense metal is used in industrial counterweights, high-density armor, and nuclear fuels? So think of nuclear. Which one is nuclear? Is it lead? Is it cadmium? Is it uranium? Or is it plutonium? So what do they use to fill nuclear reactors? Yes, they use uranium, right? So, number 53, what is the most malleable and ductile metal known? So which metal can you make into a lot of different objects? The easiest to put them into the most different objects. Is it copper, titanium, lead, or gold? The most malleable and ductile, the one that you can actually make the most items in, is gold. Gold can be made into all kinds of jewelry. Gold can be made into, gold candlesticks and anything. So it's the most malleable of all, gold. 54. Which of the following nonmetals does not have multiple allotropes at room temperature? So, oxygen, hydrogen, phosphorus, or sulfur. Okay, well, oxygen we know has 2 allotropes, and we know phosphorus has two allotropes. One is red and one is white. And we know that sulfur has quite a few. As you put it into different states, you see all these sulfur. So the only one of these that does not have multiple allotropes would be hydrogen. Now, hydrogen has multiple isotopes, so that's kind of tricky. So, but I would say hydrogen. Which of the following is an ion of oxygen? So we have the oxide ion, which is O2 with a negative, peroxide ion, which is O2 with a 2 negative, ozone ion, which is O3, or the superoxide ion, which is O2 with 1 negative. So which one? Well, there's 3 of these that are regular oxygen, and 1 is an allotrope of oxygen. So which one would it not be? Ozone is not the same thing as oxygen, so we would put C. Ozone is not an ion of oxygen. It's its own ion of allotrope of oxygen. So let's see, number 56. What element exists as an unstable white allotrope and a more stable red allotrope? I went over that already. Is it iron, phosphorus, magnesium, or sulfur? It comes in 2. Which one of these just comes in 2 red and white allotropes? Of course, it would be phosphorus. True and false. So, number 57. An alloy of mercury with another metal is called an amalgam. What is amalgam? Amalgam is actually silver mixed with mercury. So when you think of mercury, so an alloy of mercury would be amalgam. Amalgam are those silver fillings they used to put in our mouth, and they mixed it with a little bit of mercury. So that is true. Amalgam is mercury, in which now we have to take them out because they've found that mercury is poisonous to our body. So number 58, the form of iron produced by direct iron reduction is pig iron. Well, when you form iron, in the blast furnace, you'll get pig iron. But if you put it into the direct reduction, you will not get pig iron. You'll get a different kind of iron that they use just for steel, and you call this sponge iron. So it's sponge iron. So number 59, the active ingredient in bleach is the chlorine anion. Well, it is a type of chlorine anion, but I told you back when to remember that name. It's a hypochlorine, right? Hypochlorine is that bleach. So it's not a chlorine anion, but a hypochlorine. Number 60, the salts of phosphoric acid are called phosphories. I never heard of phosphories. That has to be false. But what would you call them? Instead of phosphates, you'd call them phosphates. Phosphates. And they would be the salts of phosphoric acid and oxygen called phosphates. Number 61. The science of extracting metals from their natural occurring materials, preparing them for use, is called, it's kind of, the beginning of the chapter is how do we get these metals out of their ores, and what do you call this process? You call it metallurgy. M-A-T-A-L-L, urgy. That means urgently we need to get those metals out. Metallurgy. True. So number 62, the addition of hydrogen to double or triple bonds is known as what? When you put hydrogen into stuff with double and triple bonds, especially into your food, to make the oils and such be solid at room temperature. What do you call these in processed foods? You call it hydrogenation, right? So that would be true. Number 63, the process occurring in plants that continually replenishes oxygen in the atmosphere is respiration. No. What is it? Photosynthesis, right? So let's go on to the matching. We're almost there. Just hold on tight. The second most abundant element. So we're going to match these. What is the second most abundant element? Well, the first abundant element is oxygen. And what's the second? Silicon, right? So silicon is H. So number 65, used in, used in refrigerants and as an anti-cavity dental treatment. What do they do to your teeth? You put fluorine in them, right? So it's fluorine, C. Number 66, used in bleaches, PVC pipes, plastics, medicines, pesticides, water treatment, all these things. It's very common in a lot of things, and they want to try to ban it sometimes, thinking we're getting too much of it in our atmosphere, especially ozone layer. So which one of these is it? Chlorine, right? Chlorine's used in lots of things. B. 67, used in deep sea diving mixtures and as a non-flammable, and this is the clue, it's lifting gas. It goes up in airships, and at high altitude, they use it in high altitude balloons. So which one of these? Yep, you're right. Helium. Helium, we put them in helium balloons, right? D. Number 68, used in ammonia or artificial fertilizers and explosives. So what's in ammonia? In ammonia is hydrogen and what? Nitrogen. And nitrogen, you call them basically TNT, the N being nitrogen. Basically, so which one of these would be? It would be F, nitrogen. Nitrogen can be an explosive in dynamite with nitrogen in it. Okay. A TNT with the N being nitrogen. 69, the most abundant element in the universe, the whole universe. When you look up in the skies, what's the most, and what on Pluto and Saturn, what's the most abundant element? It's not oxygen. Oxygen is probably just on Earth. It's what? Hydrogen. Hydrogen. So number 70, isotopes protium, deuterium, and tritium are what? It's kind of a trick question because you think, what can they be? We've already used it. So they're actually isotopes of hydrogen. So E again. All right. So we're down to number 70. Now all we have is the essay question. And I already went over the essay question a bunch of times, but briefly describe the two processes used to refine steel, which would be most useful in a country where electricity is expensive. So they don't want to use electricity. And so which one would you use and why? Well, there's two processes. The first process you can write down is the basic oxygen process. And what that is that pure oxygen is blown against this molten pig iron. So it's it basically is oxygen process is blowing oxygen at hot oxygen and everything at the iron, and it causes it to go into an exothermic reaction without electricity. They need no electricity, and it actually reacts with the ore to pull out that pig iron, right? So that's the first process. The second process is the electric arc. Well, the key is the word electric, because electric arc, you need lots of electricity. And they decide basically in doing this, because there's like two different electrodes and this heat to melt this metal, and it needs a lot of electricity. Well, they do not like to put carbon into the air, right? And so they thought this electric process would give us cleaner air, right? But it heats this to melt it, and it needs electricity. So basic oxygen process would be better in a country where they don't have electricity, because they can't use lots of electricity, so they can't use the electric arc method at all. And so the electric arc method requires lots of electricity, so the process that they would use would be the basic oxygen process, which gives this exothermic reaction and doesn't need electricity. So I hope you get that. You can write that up however you want. But anyway, so I just wanted to go over these things with you, and that's going to be the end of this section with test 7 and the quizzes. And so I hope you did a good job on that, and I hope you learned some things about elements and the non-metals and the metals, the non-metals, the semi-metals, and the metals on your periodic table. And it can be quite fun if you look in today's world and see all of the things and what God has made, and how these combinations He has given us to have what we have today, whether it be computer chips or whether it be our iron pans to cook in, so whatever, or whether it be medicine or whatever. You see how all of these things, all of these metals, semi-metals and non-metals fit in our periodic table and combine into compounds to make all of the things in our beautiful world. Isn't God amazing?